Alright, here we're looking at section 10.2, and we're still dealing with circles here. So for this lesson, we're going to be finding arc measures, then we're going to identify congruent arcs, and then thirdly, we're going to prove that all circles are similar. So the first thing we have to figure out is what an arc is. So an arc is the distance around the circle, right? So the circumference of a circle is kind of an arc measure of the entire circle. So the measure of a minor arc is the shortest distance from point A to point B along the circle, right? So here we have a central angle, and a central angle of a circle is where the vertex of that is on the center of my circle. So the measure of my minor arc is the measure of that central angle. So since I also know that the measure of the entire circle is 360 degrees, the measure of my major arc, so here my major arc would be considered arc ADB, is how we would label it, would be 360 minus this 50, so 310. So arc measurements are based on the central angle that we're given. So let's look at some examples. So here we're asked to find the measure of each arc of circle P, where RT is a diameter. So I'm given some extra information. So first I want to find what the measure of arc RS is. Well, I see that RS would be right here from R to S, and I see that its angle that's included is 110 degrees. So I know that that's my minor arc, so the measure of that arc is the same as its angle measurement. So it would be 110 degrees. So let's look at B, RTS. So that's going around this long way, right, from R through T to S. That's how we can kind of follow it. So I know that that's going to be my major arc here. So it's going to be the rest of the circle. So I take that 360 minus 110, which gives me 250. So the measure of this arc is going to be 250 degrees. So let's look at part C. So now here I'm looking at RST, right? That's how I can see. Well, if I know that RT is the diameter, I know that that covers 180 degrees. So the measure of that semicircle, that arc, would be also 180 degrees. So here's my first postulate, so my arc addition postulate, which this should make sense to you. So if I'm looking at the measure of arc ABC, right, going around this side, it's equal to the measure of the arc AB plus the measure of arc BC. So if I take two pieces and add them together, it gives me the length of the entire arc. So now I can take that and with more information in my circle to help me find some measures. So here I'm looking for arc GE. So I see I've got GHE. So I want this entire arc here. So I know that I can add GH plus HE to get this entire thing, and I'm given the angle measurements there, so I can go ahead and solve that. Substitute what I know. I know that GH is 40 and HE was 80, so my entire length, my arc length here would be 120. So now let's look at B. Here I have 3 letters, so whenever I have an arc with 3 letters, I know that that's going to be a major arc. So here I'm looking at arc GEF. So again, I'm adding GH, I'm adding HE, and I'm adding EF. So then I can substitute the things that I know, and I found that GE was 120, so I can use that, plus 110. So this entire arc length here is 230 degrees. So now let's look at GF. So since I only have 2 letters, I'm going to go the shorter distance here. So if I know that my entire circle is 360, and I found that this entire side from G to F the long way was 230, I just go ahead and subtract that from 360 to find the measure of this arc GF over here. So again, I can just add the little pieces that I know to get the entire length that I'm looking for. So here, we're looking at kind of a word problem. So a recent survey asked teenagers whether they would rather meet a famous musician, athlete, actor, inventor, or other person. The circle graph shows my results. Find the indicated arc measures. So here I'm given just a circle, again, with the data that I'm going to need. So I have to find my arc measures. So first I'm looking from arc AC. So here we're going from A through B to C. And I know I'm going the shortest distance, so this is where I'm going. So I see I'm adding the inventor and the musician, so I go ahead and just write those out. I'm looking for AB plus BC, which is 29 plus 108, which gives me 137. So now here we're looking at part B, where I'm looking for the measure of arc ACD. So again, I see I have 3 letters, so I know I'm going to go the long way. So I go A through C to D. So here's all of the pieces I'm adding. I'm going to add the inventor piece, the musician piece, and the athlete piece, because that will get me all the way over there. So I can just add what I found in my first part, plus this extra 83 degrees, which gives me a total of 220 degrees. So part C, I'm looking for A, D, C. So I'm going to be going this direction now. So I can add in all of the pieces that I have, or I can take my 360 minus AC that I found earlier, or I can add these pieces together. Either way, I will get the same answer. So here we took 360 degrees and we subtracted what we found for AC and ended up with 223. You'll notice if I was to just add these 3 pieces together, I will still get this 223. So let's look at part D. We're looking for the measure of EBD. EBD, all the way around. So I'm going to go ahead and take 360, take my entire circle, and subtract the piece that's left over that I'm not looking at. I could just add all of these together, but I want to do the least that I need to, so there's less room for error. So I can go ahead and take this 360 minus the measure of arc ED, which is 61, and find that the measure of this arc, this major arc, is going to be 299 degrees. So here are the first few that I want you to try on your own and see how you can do. So now here's our next theorem when we're talking about congruent circles, right? So 2 circles are congruent if and only if they have the same radius. So at this, I'm going to start looking at radius length to determine if my circles are congruent. So here's our next theorem with circles, dealing with central angles and arc lengths. So in the same circle or congruent circles, this does not have to be the same circle, 2 minor arcs are congruent if and only if their corresponding central angles are congruent. So here in this example, we're looking at the arcs in the same circle, but we could have 2 separate circles and be looking at them as well. And I know that the arc length is congruent if the angle measurement is congruent as well. So here's our first example for this. So tell whether the red arcs are congruent and explain why or why not. So here in part A, I see I'm dealing with 1 circle, and I see that my central angle here is 80 degrees and my central angle here is 80 degrees. Since my angle is the same and I'm dealing with 1 circle, I can say that yes, these arcs lengths are the same measurement. So then let's look at B. So here I'm looking at 2 different circles. These 2 circles are not congruent because I see that one is smaller than the other, and the radius length is different. So here, since my circles are not congruent, my arc length is not the same. And I know that because my circles are not congruent. If my circles were congruent, then my angle would be the same, but they're not congruent here. So let's look at C. So now here in C, I'm looking at 2 different circles. So the first thing I want to look at is, are my circles congruent? So here I'm told some information about the radius length. Since I have this 1 dash in both of the radius lengths, I know that that means they are congruent. And I know that if circles have the same radius, then the circles themselves are congruent. So I know I have congruent circles, and I see my central angle is the same, is congruent. So I know that my arc measurement is congruent as well, which is just what this is saying. So it's the same exact length and measurement. So I want you to try these and tell me yes or no, and why or why not. So now here's our final theorem. And this we're not actually going to work through the proof of. This is just something we know. And this is our final learning target. The thing we need to know here, that all circles are similar. And remember that similar figures means I can multiply one figure by a constant term or that rate and get to the other circle. So this just tells me that all circles are going to be similar. So that's just something we need to keep in mind and know for this. So we're going to look back at our learning targets. Our first one was to find arc measures, which we were able to do using central angles of circles. Then we identified congruent arcs, and we found out that we know arcs are congruent if they have the same angle measurement and the circles are congruent. Then the third thing we just need to know and prove that all circles are similar. So now that we've worked through these learning targets, go ahead and work on the homework for 10.2.